looks like that. And all the time, all over the universe, this is what's happening. There's this structure, typograph that represents space, and that structure is being continuously rewritten. And that progressive rewriting is the progress of time. And that kind of, this particular model of sort of the irreducible progress of time, this phenomenon of computational irreducibility that I mentioned before, is something that is fundamental to the progression of time. That also explains how thermodynamics works and a bunch of other things. That there's this kind of notion of computational progress is the progress of time. Well, so the first thing you might say is, okay, that's great, but how can that possibly be right? We've known since 1905 this idea of special relativity to kind of say that space and time are sort of the same kind of thing. How can you be saying that space is the extent of this spatial hypergraph and time is this progression of computation of time? Well, it's a little bit subtle, but here's how it works. So what happens is, when you are an observer embedded within this universe, so you're part of this hypergraph, there's a question of what can you actually tell about what's going on in the universe. And it turns out the only thing you can tell is about updating events and the relationship between updating events. In a sense, what you can see is every time one of these rules gets applied, it's like a little event that happens. It's a little thing that happens to this network. And you can ask the question, when you look at those different events that happen, what is their causal relationship? That is, an event may be not able to happen yet because the input that it needs has to come from the output to some other event. And so that defines kind of this partial ordering of events that defines kind of this thread of causality, this set of causal relationships. And from that, you build this kind of causal graph that represents the causal relationships between events. And it's, in a sense, a very extreme version of this. Imagine you're an observer in this universe. And imagine that in the universe, only one event is ever happening at a time. But where that event happens kind of runs around all over the universe. You might say that theory can't possibly be right. After all, I can see that things are happening elsewhere in the universe. But the point is, you don't get to see anything until that event has come to you, so to speak. So as that thing zips around, you're kind of frozen until you get updated. And you can't tell what's been updated until you're updated. And anyway, in the end, what you realize is the only thing you can actually sense is this kind of causal network of the causal relationships between events.